Okay, this is number 22 from section 9.1, and some more of these great geometric series. And again, find the interval of convergence and the function represented, the function of fx represented by the geometric series. So this was our geometric series on number 22. Okay, the summation n equals 0 to infinity of negative 1 to the n, x plus 1 to the n. Now what I can do is this is nice notation, but I can combine this so I can get an idea of my r, my common ratio. It's a geometric series, so I do know that there's going to be an r. So I'll take a look at this. So I'll combine these and put these both under the n. And we use this technique a lot in this course. All right? And then I can generate some terms, and I can see when n is 0, I've got 1. When n is 1, I've got negative x plus 1. When n is 2, I've got positive x plus 1 squared, etc. So it looks like my ratio is going to be negative x plus 1. And it looks like my a sub 1, or my first term, will be 1. Okay? So now, when will this converge? Well, it depends on x. See, so we do have a situation there. It's going to be for some value of x. All right? When this is going to be when the absolute value of this is less than 1. So we just say the absolute value of negative x plus 1 is less than 1. Well, if I take the absolute value of negative, that's just going to be positive. So I just have to worry about x plus 1 being less than 1. Don't have to worry about the negative, because if I put that under an absolute value, I can separate that to be the absolute value of negative 1, which is 1, and I just have this. And then I break this up into x plus 1 is less than 1 or greater than negative 1. Add 1 to both sides, and subtract 1. 1 minus 1 is 0. Negative 1 minus 1 is negative 2. So there's my interval of convergence. X is between negative 2 and 0. So that's my interval of convergence. So for those values of x, and only those values of x, this will converge. And it will converge to what? To its sum, and this is its sum. And again, we're using the same formula as we used before, and I'll write it over here again. It's such an important formula. A, or a sub 1, all over 1 minus r. Real valuable formula there. My a sub 1 is 1, all over 1 minus, and my r is going to be negative x plus 1. And that's going to be on this interval of convergence when x is between these values. Otherwise, it's not equal to that. It goes off to infinity. So we do have just a specific interval in which this is the case. This polynomial is equal to this function over this interval. And I could just make that a positive, and then I could have 1 plus x plus 1, and that ends up being 1 over x plus 2. So f of x equals 1 over x plus 2 on this interval. Okay? So these are real valuable. I have to move this out a little bit for you. Sorry about that. So these are real valuable problems to really master. This is going to be about what we're going to be doing, a lot of this stuff. There we go. Let's try to get everything as big as possible. All right. That's 22. 23, we have this function. Looks a little more complicated, doesn't it? Yes. Negative 1/2 to the n. Okay, times x minus 3 to the n, and the summation is from n equals 0 to infinity. So again, I'll try to combine this so I can see what the ratio is. It's kind of hard to see what r is. We're told it's a geometric series, so we know we've got an r. We just have to find that. So let me set this over here for you. Here we go. All right. Hopefully you can see that. You can always zoom in if you can't catch some of this. All right. So I'll combine this, and I'll put this all under 1n. So I've got negative 1/2 times x minus 3 to the n. And I can simplify this. There's nothing wrong with that. It's all to the n now. It's all in the same radical. So I could say negative 1/2 x, and then positive 3/2, and then I can reverse that, and I can have and simplify to be this. So actually I can just put the negative, and I can make that negative x plus 3, or 3 minus x, and all over 2. So it's not too hard. And that's going to be my ratio because I just keep multiplying by that. When n is 0, this is 1. When n is 1, it's one of those. When n is 2, it's two of those. So there's my ratio. So I had to manipulate it around, but you can see that that's your ratio. Try to look these over and work through these because these will establish a technique that you need to be competent with in order to be going on through the chapters. That's why these problems are very excellent, helping you build up these skills. All right? So you take a look at it, you can see that my a sub 1 is 1, and what's my r? 3 minus x over 2. That's my ratio. So when will this converge? It will converge when the absolute value of r is less than 1. All right? So we can just negative x, 3 minus x over 2, negative 1 is less than 3 minus x over 2, which is less than 1. That's how we can switch the absolute value to this inequality, this double inequality. Then if I multiply through by 2, I get negative 2, 2, and then 3 minus x. I can multiply by a positive. And then if I subtract 3, I got negative 5, and I've got negative 1, and negative x. And then what I'm going to do is I'm going to multiply everything by a negative sign, and if I do that, I've got to reverse the direction of the inequalities. So this becomes positive 5, which is greater than x, positive x, which is now greater than 1. And then I'll flip these around because I want the arrows pointed to the left. So I got 1, x, 5, arrows pointed to the left. That means x is between 1 and 5. So there's my interval of convergence. Okay, pretty nifty, huh? Okay, now we go back and we use our function. So again, we're going to use this very, very important formula. S equals a, or a sub 1, all over 1 minus r. I should be consistent on that. I just kind of alternate back and forth. I used a sub 1 here, so I guess I should use a sub 1 in my formula. I'm used to that from the our algebra 2 approach. Okay, so there's my a sub 1 is 1, and my r is, so it's 1 minus r, and this is my r. So now I have some algebra to do. Common denominator. I could have multiplied the top and the bottom by 2, and that would have taken care of it fast, but while I was doing these, I was just thinking in fractions. So that's going to be 2 over 2 minus, got to be careful there. This minus is on this whole fraction. 3 minus x, so that's going to be 1 over, and that's going to be 2, and that's going to be negative 3 plus x, all over 2. And this is going to be the same thing as x, and then 2 minus 3 is what? Negative 1, so it's going to be the same as x minus 1 over 2, and invert multiply 2 over x minus 1. So there's your function on this interval. So when x is between 1 and 5, all this can be represented by this. Okay? F of x equals 2 over x minus 1. Okay, I hope that helps.